Welcome to Gadongos.
Welcome back to the channel, everyone. Today we're diving into one of new topics of our channel, astronomy, the formation of our solar system. It's a story that spans billions of years, filled with incredible events and cosmic processes that shape the world we live in today. So let's get started. About 4.6 billion years ago, our solar system began as a giant cloud of gas and dust, known as a solar nebula. This nebula consisted mainly of hydrogen and helium, with traces of heavier elements that had been formed in earlier generations of stars. Over time, something triggered this cloud to collapse under its own gravity. This could have been the shock wave from a nearby supernova or the gravitational influence of a passing star. As the nebula collapsed, it started to spin. The conservation of angular momentum caused it to flatten into a disk. Most of the material was pulled toward the center, forming the proto-sun or the early sun. As the proto-sun grew, it heated up, reaching temperatures in the millions of degrees. This intense heat triggered nuclear fusion in the core, marking the birth of our sun. Meanwhile, in the surrounding disk, particles of dust and ice began to stick together through a process called accretion. Over time, these clumps grew larger, forming planetesimals, small bodies that would eventually become planets. These planetesimals collided and merged, gradually building up to form the planets we know today. In the inner part of the solar system, where temperatures were higher, rocky materials were more abundant. This area favored the formation of the terrestrial planets: Mercury, Venus, Earth, and Mars. These planets are composed mainly of rock and metal. They formed from the accumulation of smaller planetesimals that collided and fused together. On the other hand, the outer part of the solar system was much cooler, allowing for the formation of gas giants. Jupiter and Saturn, for instance, formed in this region, where hydrogen and helium could condense into massive planets. They started as large, icy bodies that accumulated gas from the surrounding nebula. Their immense gravity allowed them to capture and hold on to thick atmospheres, making them the colossal planets we see today. Uranus and Neptune, the ice giants, formed further out, where conditions allowed for the accumulation of ices like water, ammonia, and methane. These planets are smaller than Jupiter and Saturn, but still possess significant atmospheres and unique characteristics. As the planets formed, their gravitational interactions influenced one another, leading to a chaotic environment. Some planetesimals were ejected from the solar system, while others collided with the growing planets. This period was marked by what we call the late heavy bombardment, a time when many impacts occurred, shaping the surfaces of the inner planets. Over millions of years, the solar system settled into a more stable configuration. The planets cleared their orbits of smaller debris, establishing the paths we recognize today. The leftover material formed other bodies in the solar system, like asteroids and comets. The asteroid belt between Mars and Jupiter is a remnant of this early solar system, containing leftover planetesimals that never coalesced into a planet. As we explore this topic, it's important to note that our understanding of solar system formation continues to evolve. Observations of distant star systems and advancements in technology are helping astronomers piece together the puzzle of how other solar systems form, providing insights that refine our own history. So, what about Earth? Our planet formed around 4.5 billion years ago and underwent significant changes during its early history. It likely experienced a period of heavy bombardment, where impacts from asteroids and comets played a crucial role in shaping the surface and possibly delivering water and organic materials. These elements are essential for life as we know it. As Earth cooled, a thin crust formed and volcanic activity released gases, creating an atmosphere. Over time, water vapor condensed to form oceans, creating the conditions for life to emerge. This process took millions of years, leading to the rich diversity of life we see today. In conclusion, The formation of the solar system is a complex and dynamic story that showcases the interplay of gravity, materials, and time. From a swirling cloud of gas and dust to the vibrant system we inhabit now, understanding our origins gives us a deeper appreciation for our place in the universe. Thanks for joining me on this journey through time. If you enjoyed this video, don't forget to like, subscribe, and hit that notification bell for more content on astronomy and science. Until next time, keep looking up.